Okay, YouTube, in this last video, we're going to look at finding the zeros of a function. And I just really quickly would like to recap what we mean by a zero of a function. We mean that these are any x values that when we plug them in, we get 0 for an output. And recall that this is really a y value right here. So what we're really looking for are, if we express this as an ordered pair, when we plug in this x value, getting a y value of a 0, this would lie at least on a graph if I had some graph of a parabola here. Its zeros would be its x-intercepts, okay? So these right here are x-intercepts. That's what we mean by the zero of a function, and that would be these values right here if they exist. Recall that a parabola, I suppose, could open up here and never have any x-intercepts, or we could have a parabola that comes down and touches just at its minimum, say, or maximum at its vertex, and have just one x-intercept. But when we're asked to find the zeros of a function, what we're really being asked to do is set y equal to 0, set equal to 0, and then solve for the x values that cause this to be true. So what we're going to do in this video is really quickly here, we've got this function f of x that is certainly a quadratic function, and we are going to solve for its zeros. So the first thing we want to do is this. We're going to, oh, it went away. Let's try this again. We're going to set f of x, or the y values, equal to 0, and then we're going to solve for x, basically. And these are the only two steps we need to pay attention to. So I notice my f of x here, we're going to say let's plug in 0 for that, and we're going to solve this equation for when it equals 0. So I could solve this by graphing or factoring or square roots. I notice though that we have a squared quantity. So if we could get the squared quantity on, by itself on one side and just a constant on the other, we could use square roots to solve this. So that's the method I'm going to choose to use here. I'm going to subtract 70 from both sides. And so on the right side now we would have 7 times x squared is equal to a negative 70. And then certainly I could divide both sides by the 7 here to get the squared quantity by itself, get it isolated. We say x squared is equal to a negative 10. So now we'll take the square root of both sides. And what I determine here is this. I'm going to kind of bring it over here. We say then just x equals plus or minus. Now, because I'm taking the square root of a negative, we'll put the I up front and say this is plus or minus 10i. So the note we want to leave here is this. We got non-real zeros. And basically what this means is we're going to have no real x-intercepts when we go look at this graph. And also this, it never intercepts. Now let's try to rewrite that. Intercepts. We'll say intersects the x-axis. So the one thing I wanted to do in this video was verify this graphically using a graphing utility. So I've got my graphing calculator here, and I'm going to go up to my y equals menu. We're going to put this in. So we're going to say 7, x key is right here, and then we'd say I could use my power of 2 button, so 7x squared, if I can click on that, plus 70. And the thing is, I'll go ahead and click graph just to show you what's going to happen here. You're not going to be able to see it. It is indeed graphing. But we can't see it, and the reason why is because, well, if we want to say, well, what form is this in? I would be willing to go so far as to say that this is in standard form, but vertex form. So really what I could say is our h value here is 0 and k is 70. This would be some parabola that when I graph it has its vertex up at 0, 70 to begin with, and has an a value of 7, so it's going to be like, really kind of, I say, vertically stretched by a factor of 7. So what I'm going to need to do here in my graphing utility is go to my window setting, and it'll say how far left do we want to go x min, how far right do we want to go x max, and what do we want our x-axis scale to be. It seems to me that our x-axis is not the issue here, it's the y-axis that we're going to have to go up on. So what I'll do is I'll change from y min to equaling say negative 10. Actually, we'll leave it at negative 10, but we'll go up to 100 on our y-axis. And what we'll do is we'll change the y scales going by tens. It's going to count by tens for us instead. But when I hit graph this time, you can certainly see that our parabola is shifted up 7 units here, which is representative of 10 each time. So we say up 70, and is somewhat slimmer. But what you see is this. When I said go find the zeros of this function, we knew that going into this, we weren't going to get any real zeros. And so that is why when we solved this, we actually did indeed get 2 complex zeros here. So if you get complex zeros, it just means that your graph doesn't ever hit the x-axis. And that's all that means. If you get real zeros, well then those are the x-intercepts of that graph, and you'll certainly be able to find those. Cheers.